let's take our model out. It could be a liver, it could be the T-Rex. Oh, geez. Let's save the file in the right format. So I'm going to go up to a pretty high poly count here. Just smoothing out the ends of this a little bit. So I've painted some broad texture on here, and then let's paint some detail on here as well. So we can get a sense of how this will translate. So typically from here, you would export your texture maps. Okay. So we'll set up a displacement map and a normal map. And this part, I think you guys have been through. The one thing I wanted to double check here, though, is that so we'll look at our displacement map first. And remember, the key for either using a displacement map or a bump map is that the file is a black and white file, and basically you're translating a numerical value from 0 to 1 when that information is going to your model and into the renderer. When you're using your normal map, it's an RGB value, and the RGB numbers 0 through 256 or 0 through 1 in RG and B translate to the X, Y, and Z values. And theoretically, from a little bit more research that I've been doing, the normal mapping tends to render a little bit quicker, but it's pretty subtle. So what I want to do with the displacement map, though, I want to change the method to ray casting to see what I've been noticing is when you take the displacement maps out of Mudbox, it's giving a pattern of the low-res model, or it's putting a pattern of the low-res model onto the displacement map. So I want to see if this will change it. Just a theory. And we'll take a higher resolution mesh. And I'm finding that if we're using something as a displacement map, I think we confirmed this the other day that the EXR at a 16-bit or 32-bit format does have has a noticeable improvement on the quality of the displacement. So if we're going to use it this way, go ahead and use this format. So that covers our displacement map, our normal map. Let's go back to the subdivision setting here. That seems to come out okay when we're coming out of Mudbox. And for this one, I'm just going to create a JPEG because we're using RGB values, so the alpha information isn't particularly useful. All right, so we'll do our extraction. Tangent quality on the target mesh is low. Okay, whatever. So if we come back to Maya, okay, so if we have our standard surface shader on here, what we had been doing when it comes to the normal map is that I had been recommending kind of following the traditional Maya protocol to include the normal map in the bump channel. So let's follow that for a second here. We know we're using a normal map, so we're going to change this to tangent space normals. And we're going to grab our what's going on with the system today? All right. So here's our normal map. Okay, and if we look at that in the viewport, we can see that it is indeed translating onto the object. And again, as a reminder, we need to change the color space to raw in order to get the file to read correctly. Now, what's interesting here is that it looks like it's reading properly in the viewport right now. But the problem that I was having the other day was that it looked like it was inverted on the actual model. And indeed, if you look at this now, you can see that this looks pushed in instead of popping out, right? So we're seeing the correct representation in the viewport, but Maya has decided to render this inverted. That's a big WTF and had me scratching my head the other day because I was like, come on, we can't, this has to work and work properly. And going between Mudbox and Maya, you're not supposed to have to flip normals and y-axes and all that stuff. So what do? We've got this, we've got the original, we've got this now mapped on. And what I found in trying to dig into this is that there's a new recommendation for Arnold 5 now that to not map this into the bump, not map your normal map into the bump channel, but instead to grab the AI normal map node. Okay, so no more bump mapped into the normal camera the way we used to do it. Now we're taking the out color into the input of the normal map and the out value into the normal camera. Okay, and what's interesting about this is that this node actually gives you the ability to make some adjustments to the normal map as well, which we didn't have previously. But like everything else, you can't have something good without having something taken away from you. So using this node is not going to show the normal map in the viewer. Okay, so you can see there's no more normal map visible. But if we render this now, ta-da, we have our normal map, and it looks like it's popping out in the correct direction. So if we go back and look at, this is what we had before, now we have it performing properly. And what I'm curious about, and did get a chance to test earlier, is how effective is this strength? So you can, this is interesting because you can actually make some adjustments. I don't know that that's necessarily a desired effect, but you can make some adjustments to the strength of the normal map, which is definitely a benefit. Although if one is representing what you painted, it doesn't look like going above that is going to give you much of a desired effect. But it might be the difference between having to go back and repaint a map. However, if you wanted to reduce the effect of the normal map, that's a definite bonus. And you can see here, I just dialed that back so that it's really subtle. Maybe finding a happy medium. Cool. So this is where previously with the bump map, you could adjust the strength of the bump map. Previously with a normal map, you couldn't adjust the strength of it, but now we've got the capability to do that by using the AI normal map node. Okay. So that's the one thing that was cool and new. Take a look at our EXR file real quick before we start playing around with that and just make sure that that's in decent shape. Bear with me while I sign in for the 1000th time. All right, so we go back to our standard shader for a moment now. And this time, we're going to load our displacement file. There doesn't appear to be an AI displacement shader yet, but I suspect, like everything else, they'll probably make something to accommodate that. If we take a look at this now, I'm going to reduce the scale temporarily. completely reduce it so we can test our render. Reference for that. And then we'll scale that to 1. Do our render. Okay, and you can see our displacement texture actually translated nicely here as well. So the difference between the question Austin had last night was the difference between the displacement texture and the normal map. Normal mapping and bump mapping, but the best way to think about it is they're illusions. They aren't really changing the surface of your object, but your displacement map is actually physically altering the surface of your object. It's just important to keep that in mind. So if I were just walking past this T-Rex conceptually in an animated film here, I could probably get away with a normal map. I don't really need to see the displacement, but if we're zooming into the skin and we want to see all the detail that's happening here, then we would definitely need to see that displacement. Just remember too, when you're rendering displacement, we do have to go down to the subdivision node here and adjust our Cat-Clark iterations. And what's interesting with this, as I rendered it now too, because we're using the EXR file, it doesn't look like it actually looked like it was interpreting the displacement correctly in that file. As opposed to earlier when I was trying to demo this with the JPEG and some other file formats, TIFF format and that sort of thing. So if we compare this to our previous render, you can see, and this is probably the most important thing, you can see that the rest of the T-Rex is maintaining its shape. It's not turning into a marshmallow T-Rex, but now we're getting the bump map to read correctly. So that's coming out of Mudbox, and we haven't had to adjust the scalar 0 value to get the T-Rex to be correct. And we can control the displacement, the amount of displacement, by the displacement node. So if we do scale this up, it scares me to think what we might get, but that's pretty interesting. You know, starting to get into dragon territory now. That's pretty cool. But again, the most important thing is that it seems like with the 32-bit EXR format coming out of Mudbox, we're maintaining surface consistency. And the one problem I ran into yesterday when I was talking to Austin was that when I used the particular setting that I had used in Mudbox when I was exporting the map, gave me just a weird interpretation of the difference between the low resolution mesh and the high resolution mesh. They made it almost seem like it was tessellated, that the low res was tessellated. But here you can see I mean, this is incredible detail in this texture map. And if we were to zoom into this now, and take a look at it. Hopefully I've got this framed well enough so that we can see the detail. And that's looking pretty cool, and it's holding up really well. I'll dial this back just a little bit so that we can see a better render of it. And it's not taking a tremendously long time to render, considering we've got lights and shadows being cast and everything else as well. Okay. So just to review then, if you're working with the displacement maps, the key seemed to be that coming out of Mudbox, that you want to, oh, that's interesting. It looked like it changed the map on option on both of those. So for whatever reason, though, the subdivision method worked there. I thought I had switched it. Regardless, the EXR 16-bit or 32-bit EXR file out of Mudbox gave you a clean file to import into Maya, and the offset on the surface didn't seem to be an issue there, whereas previously we had been having some problems with that. And then your normal map, again, because this is an RGB file, I just saved that as a JPEG, and it looked like it translated just fine into Maya. But remember that we need to then use the AI normal map node to give us the results that we would expect. And the downside to that is that you can't see your normal map on your object. So if you were trying to add some detail to a motion test, what I might suggest would be to create a second shader and just take your normal map. So if you want to see it in your, see the normal map appear in your viewer, you could have a second shader that has the normal map on it, and then just switch that out. And you can see I just use the same normal map too, so that gives me the option here. And then when I go to render it, again, because we've got the inverted normal map, I can just switch my shader at the end and get the correct rendering. Okay. So in the past, the methodology might be to use a displacement map for broader displacement or broader deformation, and then add a normal map on top of that for the details. So in this case, maybe I would use my displacement map for the long tube structures and then use the normal map for the scale detail. But I think you can see with the detail that I was getting off of the displacement map, I don't see any reason why you would need to add a normal map on top of that unless you were trying to add even finer detail. So it's kind of like if you wanted to paint all your I'm just trying to think of something like, let's say you're making a pancreas or something like that. Maybe you would paint the individual lobes or the individual surface lobules, paint those with a displacement map, and then take the normal map and do like a really fine texture on to that, so that if you were to zoom into the pancreas really close, you could see that fine texture, but you'd still see the displacement of the surface as well. Does that make sense? Endothelial cell might be another good example. If you were creating a vessel, maybe you use the displacement map for your endothelial cell to give that particular texture, and then use the normal map to paint some fine, really fine noise texture on there, something too, just to rough it up even a little bit more. Okay? So I kind of feel like with all this here, I think we've got the workflow down now, finally, in a way that makes sense. The other day when we were looking at this and we were dealing with the TIFF files and target files for the displacement map and having to deal with the offset and everything too, I mean, that method works. It's slightly more cumbersome, but it seems like this this finally gives us a solution that we can work with.